Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad HASSANUDDIN. Me and my partners from Group 8, Muhammad IMRAAN, MASLIZA and ATHIRAH will be presenting to you guys our service learning, which title is Introduction to Chemical Engineering and Distillation and its Application. Okay, so we're gonna talk about what is a chemical engineering. Before that, we move to the introduction to engineering. What is an engineer? Engineer is a professional who invent, design, analyze, build and test while considering the limitations imposed by practically regulation, safety and cost. There are many types of engineering such as chemical engineering, mechanical, electrical and civil. After that, we move to the definition of chemical engineer. What do you guys think the chemical engineers do? Working in the lab, do tons of experiment, only relate with chemical reaction, same with chemistry? No, we are not. What we actually do, which is we processing raw materials into something useful. Chemical engineers apply the principle of chemistry, biology, physics and math to solve problems that involve the production or use of chemicals, fuel, drugs, food and many other products. After that, where do we work? We work at the industrial plant, refineries, laboratories and offshore. And what is the difference between chemical engineering and other engineering? Chemical engineer is one of the most demanding engineer with higher average salary due to our knowledge and flexibility in taking skills such as salary, flexibility, demand. Next, you guys might be wondering what is the scope of study to become a chemical engineer. As chemical engineer, we always hungry for knowledge and urge to learn something new. Some of the knowledge can be gained by further studies and some from entering the career life of jobs. Some of the courses that will be taken to become a chemical engineer such as mass balance, energy balance, fluid mechanics, separation process, chemical reaction and waste management. And the job scope for chemical engineer, which is chemical engineer itself, petrochemicals, process engineer, healthcare, safety industry, design and others. That's all from me. I will pass to my friends to continue to explain about the distillation and its application.
In this video, we will briefly explain about distillation. As a chemical engineering student, this topic is one of the many processes we learn in separation process. Let's go to the first part, which is the history of distillation process. The earliest known evidence of distillation comes from a terracotta distillation apparatus dating to 3000 before century in the Indus Valley of Pakistan. Distillation was known to be used by the Babylonians of Mesopotamia. Initially, distillation is believed to have been used to make perfumes. Distillation of beverages occurred much later. The Arab chemist Al-Kindi distilled alcohol in 9th century Iraq. Distillation of alcoholic beverages appears common in Italy and China starting in the 12th century. We will move to the definition of distillation. Distillation is the process of separating components of a mixture based on different boiling points. This is the simplest experiment to show us how this process works. The first part, which is evaporation. To separate a mixture of liquids, the liquid can be heated to force components which have different boiling points into a gas phase. Next, the gas is then condensed back into liquid form and collected. Then, the distillate which has been collected is the interest compound of the process. Repeating the process on the collected liquid to improve the purity of the product is called double distillation. The distillation column is an essential item used in the distillation of liquid mixtures to separate the mixture into its component parts or fractions based on the differences in volatilities. Fractionating columns are used in small-scale laboratory distillations as well as large-scale industrial distillations. Vertical shell houses, the column internals, and together with the condenser and boiler, constitute a distillation column. A schematic of a typical distillation unit with a single feed and two product streams is shown below. The liquid mixture that is to be processed is known as the feed, and this is introduced usually somewhere near the middle of the column to a tray known as the feed tray. The feed tray divides the column into a top enriching or rectification section, a bottom stripping section. The feed flows down the column where it is collected at the bottom in the reboiler. Heat is applied to the reboiler to generate vapor. The source of heat input can be any suitable fluid. The vapor raised in the reboiler is reintroduced into the unit at the bottom of the column. The liquid removed from the reboiler is known as the bottoms product or simply bottoms. The vapor moves up the column and as it exits the top of the unit, it is cooled by a condenser. The condensed liquid is stored in a holding vessel known as the reflux drum. Some of this liquid is recycled back to the top of the column and this is called the reflux. The condensed liquid that is removed from the system is known as the distillate or top product.
Next, I will explain about the flow of the process. The distillation column is made up of a series of stacked plates. A liquid feed containing the mixture of two or more liquid enters the column at one or more point. The liquid flow over the plates and vapor bubbles up through the liquid via hole in the plates. Liquid travels down the column. The vapor comes in contact with it several times due to multiple plates, known as critical process in distillation columns. Some vapor escapes from the top of the column and is returned to a liquid state in the condenser. Some of this liquid is returned to the column as reflux and the remainder is the top product or distillate. The liquid removed known as bottom product or waste. McCabe-Taylor plots provide a simple graphical tool for analysis of binary distillation, specifically the determination of the number of tray required. How to calculate number of tray using McCabe-Taylor method. Step 1. We need to design the distillation column. Step 2. Complete the information which is cover the molar flow rate and composition of each stream. The next step is we need to draw a 45-degree line, equilibrium line and also enriching line. Then we need to mark the composition of feed, top and the bottom product in x-axis. The next step is to draw the Q line and stripping line. Q line need to meet the 45-degree line until intercept the VLE curve. Step number 6 is stepping down the plot. Starting from the XD, make a step between equilibrium line and enriching line to Q line. Then shift to stripping line after passing the Q line. The last step is counting the trays. The number of theoretical trays can now be determined by counting the number of steps starting at the top right and moving to the bottom left.
Now we are going to look at the application of distillation. Distillation is one of the most important processes that, without us noticing, is part of the process of producing substance for our daily life usage. The process is used regularly in chemical and pharmaceutical research, quality assurance, testing for many consumer products, and law enforcement forensics. There are few applications of distillation in the industry itself. For example, oil refinery. Oil refinery is basically a process where the petroleum is transformed and refined into several useful products such as gasoline, diesel fuel, lubricating oil, fuel oil, and many more. This process can be done through the fractional distillation process to separate the crude oil into these materials. Next, we have medication. Medication is also one of the most important productions in the industry that requires the usage of distillation process. The process of the industrial scale synthesis of pharmaceutical drugs by pharmaceutical companies. Inside the pharmaceutical industry, the distillation process is generally utilized to remove or exchange one or more solvents in the preparation for isolation of an active ingredient or intermediate efficiently. The main part of medication sectors that uses the distillation process is the drug manufacturing, which is essential on providing medicine towards individual that needs it. The medication sector prioritizes consistency and purity of the product, which promotes several purposes in the industry and also the society. As for the application in our daily life, it is involved in one of the most important basic needs as a human being, which is the production of pure drinking water. Water naturally contains a variety of minerals and also other impurities, which is generally removed by distillation. The process of producing pure drinking water involves the boiling of water until it evaporates and condenses, leaving behind impurities with different boiling points. This process happens in a large scale as it is important to provide thousands of gallons of water for drinking.
That's all from us. We hope you guys enjoyed the video. Thank you.